Okay, so today's lesson we talked about quadratic graphs and a lot of the properties that a quadratic graph has. And so what we have to do on your homework is we need to find some of the key things that are related to a quadratic graph. So I'm going to do number 6 here. So it's y equals negative x squared plus 16x minus 70. Okay, and keep in mind that this y is the same thing as f of x, where I could pick an x value, plug it in, and get an output. Okay, so we typically think of this, the y as being like if we're graphing it, and the f of x as being like the function machine. Like I pick an x, I put it inside of the parentheses, maybe like 2, and then I say, well, what's the output? Okay, what is the y value? Okay, but they're the same thing. Okay, so on this homework, you have to find the vertex, okay, which is also known as the turning point. So I need an xy point to go along with this. We need to find the axis of symmetry, okay, which I'll abbreviate there, which is x equals a number, because that's going to be a vertical line that goes through the center of a parabola, okay. And then we need to find the opening direction. We need to find if it is a maximum or a minimum. And we also need to find the y-intercept. Okay. So what I'm going to start with is finding the opening direction. So what I do is I look at the a value, and this is in standard form, ax squared plus bx plus c. Okay, and so the a value is a -1, so it is negative, so it's going to open down. Okay, and if I think about a parabola that opens down, then it is going to have a maximum point, because I'm going to have a point here at the top that is the highest I can go. So I'm going to say it's a maximum, and we will find that point here in just a second. And then I just look at the c value to see what the y-intercept is, and that is -70. So y equals -70 is where it crosses the y-axis. That's pretty far down. Okay, so if you're going to graph this on your calculator, you're going to have to zoom a lot in order to get -70 to be on the screen. So now I need to find the other three things. So I'm going to start with the axis of symmetry. Why don't I start there? So I know that the axis of symmetry is -b over 2a. So you just find your a and b values and you plug them in. So it's a negative, and I'm going to plug a 16 in and divide that by 2 times the -1, that is a. So I'm going to say that my axis of symmetry is going to be at 8, -16 divided by -2. So I'm going to say that my axis of symmetry is at 8. What is nice, though, is that the vertex point is on that axis of symmetry. So the 8 of the axis of symmetry is also the 8x value of the vertex point, okay, because they are literally on the same line. Well, what do I do to find the y value for the vertex point that corresponds to the minimum value? Well, I take that 8 and I plug it in to my function. So negative, and it's going to be 8 squared plus 16 times 8 minus 70. Okay, and I recommend that you do that in a calculator so that you don't have to worry about the steps, because this is what you end up with. You end up with 64, but it's negative, and then plus, and let's see, 16 times 8 is 128, and then I got a minus 70, and when I type all of that in, which the calculator is a little bit nicer with telling me what it equals, it's just going to equal -6. So y equals f of 8, which equals -6. So -6 is going to be the y value of the vertex point, and it's also going to be my maximum value, the highest that I go. Okay? So to recap, the a value tells me if it opens up or down, so this one opens down. The c value is my y-intercept, so I put that in the y-intercept. I find the vertex point by finding the axis of symmetry first. That is my x value. Okay, see how they're related there? And then I plug in the axis of symmetry, the 8, into my function and get an output that tells me the y value of my vertex point as well as the maximum or minimum point. Okay? Hope that helps.